Hi class, today we are learning the derivative of tan x, and this is going to be a really short video. Basically, I just kind of give you what the derivative of, well, no, we're going to develop it slightly, why the derivative of tan x is what it is, and then we're just going to kind of give her and use it. So remember that tan x can be written as sine x over cos x. We learned that. Again, that's because of Pythagorean theorem, actually. So we can actually rewrite this as sine x and then cos x to the -1. So we're going to develop this derivative using this knowledge. So we're going to treat this like a like a quotient rule. I'm going to use this and treat it like a quotient rule. So when you take the derivative of this, you take the bottom times the derivative of the top, which is cos x, minus the top times the derivative of the bottom, which is minus sine x, all over the bottom squared, which is cos squared x. Now watch what happens. You get cos squared x plus sine squared x all over cos squared x. Okay, do not cross those off. Don't. It's addition. Don't you dare. But remember your Pythagorean identity that cos squared and sine squared actually simplify to 1 over cos squared x. So the derivative of tan x is actually just 1 over cos squared x, which is secant squared x, because secant is the reciprocal function of cos. So there you have it. That is your derivative of tan x. Secant squared x is what we usually write it as. So, basically you can use your intuition to think about what the derivative of tan is if its argument is a function other than just x. So what I'm going to challenge you to do is, just before I do each of these examples, pause the video and see if you can figure it out on your own. If you have a whiteboard or a pencil, I think you can do it. You have so much derivative knowledge at this point. So hopefully you did pause and try. So I'm going to go through and tell you now. So just think, this is tan blah. So the derivative of tan blah is going to be sec squared blah times the derivative of blah. That's it. We're done. The only thing I might want to do here is just put this 2x plus 3 out front, and that kind of eliminates... No, it doesn't really eliminate anything. I was going to say the need for double brackets. I mean, you don't really need this bracket here in front of the sec squared, but I decided to put it there. But really, that does look nicer out front. So there you go. All right, try this one. This is just blah to the power of 4. So you should treat it like blah to the power of 4. So blah to the power of 4 is 4 blah. Keep blah the same. To the power 3 times the derivative of blah. So now I do the derivative of sine x is cos x. And then the derivative of tan x is sec squared x. That's it. Okay. All right. Now this is a product rule question where I have a chain rule embedded in it. So I have x as my first function and then tan of blah as my second function. So I'm going to take the derivative of x and then keep tan 2x minus 1 the same. Then I'm going to add it to x and now take the derivative of tan blah. So the derivative of tan blah is sec squared blah times the derivative of blah, which is 2. Okay, so I can kind of simplify this to tan 2x minus 1 plus, and then I'll put the 2x together, 2x sec squared 2x minus 1. That's it. Can't do anything else. No common factoring. You can't common factor out the 2x minus 1 because it's an argument. So you're done. Okay, so the derivative of tan, where the argument is a function, is just sec squared of that function times the derivative of that function. Is this the shortest video yet, or what? Tan x, people. Good times. Thanks for watching. Hope you learned something.